Okay, we're live. Alex, did you or anyone else have any particular agenda or discussion items? I don't think anyone added anything to the ticket on GitHub.
Yeah, nobody ever adds anything. But since we have Danny and Sammy here, I think they probably have questions. So I would just start with those and answering those questions.
Okay, well, I don't actually have any questions. I work for Drupit, and well, I think Sina has been talking to you guys from Drupit, but he's now working on other projects. So I'm just checking out what's going on.
Cool. Yeah, nice to meet you, Sammy. We're a big fan of Drupit here, and I've definitely had a lot of conversations with Tina about what the Drupit team is doing with technology. Yeah, if anyone has questions for us, then please feel free to chime in with questions. If not, maybe we could kind of go down the line and each of us just give a brief update of kind of what we're working on and the status of the project. Does that sound reasonable?
I think there's actually one agenda point we could talk about. In the last couple of days, I've seen some discussion around the future of EVM-based languages versus ewasm and the connection to, apparently there was an update on the last call, all-core dev call by Vitalik with a potential roadmap on something termed Ethereum 2.0. And some people have understood those words as going forward with something based on WebAssembly, or maybe more specifically ewasm. And that would mean that all of these EVM-based languages would kind of be deprecated and wouldn't really have a future. So maybe that's a good topic to talk about. What do you think, guys?
I think I agree, but I think we could also do the update thing just for the purpose of documenting what's going on. Maybe we could do a quick update and then talk about that.
Yeah, I guess let's do an update. Do you want to start, Everett, with your side of things?
Sure. So yeah, more naming crisis is happening because we're trying to, figure out what to name all these. We're trying to plug in, ewasm VMs, ewasm execution engines into Ethereum clients and make them, ready to run on a blockchain, and that is causing confusion about, like, are we going to have ewasm code able to call EVM code, and if so, what's the layer that kind of handles all that logic? But otherwise just been kind of gradually refactoring KVM to make it so that I can pull out these call semantics. But I don't know, I think I'm running into a little bit of the perfect is the enemy of the good crisis, because I keep not quite being satisfied with the refactorings, and it makes me not make enough progress probably. So I'm going to try to get this gas refactoring into KVM, and then I'll be able to hopefully pull out the calls into the K specification of this abstraction layer between a client and an execution engine. And yeah, that's about it. Otherwise, I've just been working on K tooling stuff, which is not very ewasm specific, but could produce an ewasm debugger, for instance, or a EVM debugger, stuff like that. So that's about it. Any questions, or we move on?
Yeah, if anyone has questions, please feel free to just speak up.
I think separately we could also deep dive a bit more into this naming discussion Everett has mentioned, but maybe do it after the stand up.
Okay.
I'll go ahead and give an update. Hi guys, this is Lane. I'm sorry, my avatar says Ethereum Foundation. I can't change it. That's just how the streaming software works. Yeah, so as people may or may not be aware, we are working now on launching an ewasm testnet. So the piece of that I've been working on is tests. So trying to write some low-level WebAssembly tests to make sure that all of the various EEI host functions are working properly or passing the test, that the layer we have, which sits in between the WASM engine and the Ethereum client that we're using, CPP Ethereum, yeah, basically is bug-free or as close to bug-free as possible. I think we may talk a little bit more about what host functions and EEI and all that kind of stuff is in a few minutes here. That sort of seems like an interesting topic to dive into. And the other thing I've been focused on is we are now talking to the Trinity team, right? So Trinity is a brand new client written in Python that Piper Merriam and Jason Carver and a bunch of other awesome people are working on, and they've just done an alpha release. So we're sort of figuring out right now how to, a specific question, which is how to integrate, how to add ewasm support to Trinity. And then a related general question, which is how to think about adding ewasm support to any Ethereum client in general. We're working on some proposals and hope to share those very, very soon for feedback.
That's great to hear, Lane. Maybe I go next. Mostly I've been working on Hera, which is the C++ VM implementation. And I also have been working on a library in Rust to implement the ewasm quote EEI, which is all the methods, as of today, all the methods a contract can access and give a nicer abstraction in Rust. And in connection to that, I've worked on a couple of current Ethereum precompiles implemented in Rust, which can be compiled directly to WebAssembly. This would be it has two purposes. One of them, the actual library can be used to write contracts in Rust. And the precompiles make sense for two reasons. One of them, they're like a good demonstration of why there wouldn't be a need to have precompiles, because one could write them as a contract. And second, it should be a good starting point to do benchmarks across different ewasm VM implementations. As Lynn has mentioned, there is work in progress to implement a native ewasm support in Trinity, which means the entire VM and the execution engine, and the execution engine is the actual part running WebAssembly. So the entire VM would be written, and the entire client in the VM would be written in Python. Whereas Hera, which is the C++ implementation, uses currently a single C++ execution engine called Binarian, but there's some work ongoing which would enable Hera to use multiple execution engines, of course, one at a time. But one of the newer execution engines we're looking at is a JIT based on LLVM. And having these precompiles and having the support for the JIT, as well as having the Trinity implementation, would enable us to do benchmarks across all of these. And having benchmarks would enable us to do a couple of things, but one of them is to determine the entire gas calculation and gas costs in a more reasonable way than we did before. So I think that's really exciting. And thank you.
I think I can go next. Well, lately I've been working on writing more test cases for ewasm and reviewing well, new test cases from Lane as well. And well, yeah, I think we are having good progress on writing new test cases. And well, Casey and Jared are not here, but they are having a good progress as well on the ewasm Explorer. So I've been trying to help a little bit on that and fixing just minor bugs there.
Hugo,
And
Hugo,
I
can
think,
you explain what the ewasm Explorer is and how it fits into the testnet?
yeah, sure. Well, currently the ewasm Explorer we have is a fork from Etherchain. So Jared and Casey adapted it to access the an ewasm node and actually show, for example, you can see the current blocks, you can see the pending transactions. Um, you have you also have a list of accounts, and you can see the ewasm bytecode of the contracts deployed to the ewasm testnet. And I think that's it.
Thanks, Hugo. Does anyone have any questions about any of the update topics? And if not, we'll move on to the other topic that Alex proposed. Cool. Alex, I think you said you wanted to talk about the naming / abstraction piece.
Sorry. Yeah, so there would be two topics I think could be a good conversation starter. One of them is these two different abstractions we have in the naming random, or maybe three different abstractions in the naming random, which may be quite a big topic to talk about. And the other one is what is the future of EVM-based languages, and if ewasm comes around, which one should we start with?
Well, the naming one seems like a more concrete discussion to me. So I would vote to start with that, but it's up to, I don't know, how concrete do you envision the other discussion being?
Well, for the other one, at least from myself, I can give my opinion and an overview just to set the scene. But luckily, we do have a couple of other people from Viper as well on the call, so they might be able to chime in and give their own view on the topic. Regarding the naming discussion, I guess we would need to start with a quick introduction to what are these different things we are trying to name, and I guess started the naming discussion from that point. I'm happy to start it with any of those.
Naming is the most important thing, okay? For someone that has come from naming Viper to Viper with a Y, I can just tell you guys, please just check everywhere where these names have been used before.
We've had trouble with the capitalization of ewasm. Is it lowercase e, uppercase wasm? Is it all lowercase? Which is not even as hard as changing a letter. So kudos to you.
Yeah, just trust me. Take it from me. Be very careful, because it turned out there was already a Viper language, like a programming language. We had to change it, so now it's with a Y. So guys, just like Google yourself flat and make sure like all the items are like, for instance, PyPy, the package managers also have those names available. It's very important. That's all I can say.
Yeah, I agree. I guess the Ethereum community kind of has a history of naming problems, huh?
Yeah.
I'm glad that you guys settled on Viper with a Y and there's no naming conflict and everybody's happy and using that name. Well, if you're on, maybe we should just quickly start with the language part, Everett, if you don't mind.
Sure.
Um,
Yeah.
Okay.
I guess I can. Well, Jack, you want to start with your view on Viper, and what the future would be with Viper if ewasm comes around, or should I start
Right,
with the Solidity part?
I'll start with what we just discussed on the. It kind of happened organically, right? So, what is interesting is like, what are the implications? Because we see these things like an EVM to WASM converter, right? And I looked at it and and we just start laughing because like all our languages, and this includes Solidity, was basically designed around this concept of 256 bits. And now we're moving to 64 bits. And the conclusion that I just made, well, overthinking it just like for 10 minutes, so just consider what I'm saying, that it's not too well thought through, is that basically like we either have to start adding new types to these languages because it just doesn't make sense to translate 256 bits. The incentives are just not there to do so because it's just so much more inefficient to write 256-bit math in 64-bit math. And then there's no incentive for anybody to ever run a contract using V1, which means we have to start adding 64-bit types to the language. So that would be my first question. Is that what's intended?
I think if you're asking about deprecation of V1, at least my personal opinion is that, yeah, we should, take steps to deprecate EVM V1. Okay. But just because it's, it's kind of a first cut and it's, it doesn't have good modularity and separation of concerns, and it has like some kind of weird things that people kind of largely agree are not good for low-level VM languages, stuff like the unstructured control flow and all sorts of other little issues. And I don't know. I think people largely agree that EVM v1 is not the ideal design of a VM. It doesn't have good separation between the Ethereum level stuff and the VM level stuff. But regarding the 256-bit and 64-bit translations, I think that's just a fact of life that we're going to have to live with. The idea behind WASM is, we're trying to make a language that maps well to hardware, so that it can be executed efficiently on hardware, and so that a lot of the standard optimization engines that exist can be applied directly to it. And the fact of the matter is that 256-bit hardware doesn't exist. It's all 64-bit hardware. So
right. So the translator would be a stopgap, basically.
You mean EVM to WASM specifically?
Yes, it would be like a type of stopgap until the languages accommodate 64-bit types.
Well, I don't know if I would like it to be that EVM to WASM is, just a stopgap, basically, just to get, just to be an initial approximation of the contract. But I would not count on EVM to WASM being a semantics preserving transformation. Right. Is what I would say. I would say, like, if you are confident in your bytecode before and then you put it through EVM to WASM, you still need to go through all your quality assurance checks on the generated WASM code to be confident in your bytecode after.
Yeah. So basically, what the conclusion I'm making from my side is one kind of has to just start from scratch in terms of the language development. Like you can take the syntax as the base, the structure of what it looks like, but basically considering like you don't everything should just start from scratch, including even the API.
Yeah, I suppose so. I don't know how much from scratch though you really have to do, because I think that a lot of that heavy lifting has been done. I think Alex would know better than me about exactly how much the heavy lifting has been done, but I think like a lot of the 256 bit encoding into 64-bit arithmetic has been done. So Alex, can you maybe talk a bit about that?
So actually, I wanted to run a. Okay, sorry. I guess I didn't unmute it. I just wanted to give a quick overview for those potential people who are gonna maybe watch this after the live stream, and just to maybe clarify some of the confusion. And that confusion is, and sorry for saying this, having all the Viper folks on the call, but it really seems at the moment Solidity would have a bigger market share. So people are really concerned what happens to Solidity if ewasm goes live. And,
yeah, of course.
But it's nothing against Viper. It's just the fact
today.
That may or hopefully will change. I actually hope there will be more languages. And just first of all, we have said this, I think, every single time we made any kind of discussion about ewasm, is it really makes sense to have domain-specific languages for smart contracts. But one of the main points of using WebAssembly is that we have access to a much bigger and much more mature tool chain. And one of those tool chains is LLVM, which enables a lot of different languages people are familiar with, but they may not be domain specific enough in some cases. But they do make sense to write heavy lifting code in. For example, the one thing already mentioned would be precompiled. So anything which would be like a utility library or a much more low-level thing that really makes sense probably to write in a language which can be optimized by all the existing tool chains, but probably higher level rules and logic very likely makes more sense to be written in a domain-specific language. And one of those would be Solidity. Another example today would be Viper, but I think there are a ton more being developed for EVM, and probably quite a few being developed for WebAssembly-based blockchains already. And for the actual Solidity in question, in the Solidity project itself, there is an intermediate language in development, which would have a WebAssembly output. But then, of course, the Solidity language will need to be translated into this intermediate language, which probably is a tiny bit bigger task, but we do expect it to happen, fairly soon, within a year. But it's worth mentioning that one of the other projects working on the K framework, of which Everett we have on the call, who is a big contributor to the K framework. K framework, based on my understanding, should be able to compile Solidity to WebAssembly at some point in the future as well. So one may not need to wait for the Solidity compiler to support this.
Yeah, I would say the Solidity compiler will probably have support for ewasm sooner than the K framework SBC stuff will be ready. That's more of a 6 months sort of proposition. But also the I think supporting ewasm from Sol C shouldn't be too hard, because it took 2 engineers here at RV only a few months to support Yele from Sol C. So I think that it should be, and Yele has different architecture for integers and stuff than an EVM does, for example. So, okay, go on.
Yeah, it's definitely not, it's not a big deal to do it. It's just a matter of time. And right now the focus isn't on that project, but it's definitely on the timeline to be one of the more important projects next. So hopefully that will happen. But as a stopgap, as Everett has mentioned, EVM to WASM could be used to translate code generated by Solidity or Viper to WebAssembly. And then I guess just a quick note on this other topic which have been brought up, whether we should keep all of these 256-bit centric designs we have currently. One of them is the ABI, the contract ABI. I think personally I would be interested in maybe looking at this in more detail and thinking about a 64-bit ABI, which actually isn't really dependent on ewasm. It could be supported by current EVM languages as well. And if the ecosystem is determined to use ewasm, which would be 64-bit, then this transition could be started even before launching ewasm. But that probably is a good idea to think about that, because whenever a contract, a higher level logic contract would need to be written in any kind of language, most of the languages aren't really designed for 256 bits. And therefore, there would be a need for a framework in any of these languages to deal with ABI encoding and everything else, which would be a common thing in writing a contract. And if that is 256-bit on a 64-bit machine, that is probably a lot of wasted effort, which doesn't need to be done. So probably in the next couple of months, that could be a good discussion point. I think that's all I wanted to say.
Sounds good to me. Basically, from since we're a very small team, as in it's just me currently on permanently on Viper. The way I see it is, I would start with a second version of Viper that specifically targets 64-bit, and all the types would specifically be catered for that, including the in-memory bytes, because that also changes. So, kind of like writing a second version, but just keeping the lessons we've learned from the syntax side.
I don't know if it's even necessary to be that extreme though, because the already in the EVM to WASM repo, there are a bunch of chunks of WASM code that directly do the 256-bit arithmetic over 64, over the 64-bit representation, just handling chunks of them at a time. So I think the approach I would think is okay, add the 64-bit types to Viper, and then when you're emitting EVM code, just round it up to 256 bits, and then when you're emitting WASM code, if it's a 64-byte, use the native, and if it's the 256, just emit the chunk of WASM code that handles the 250. So I'm just saying, I don't know if you need to worry too much about it at that layer, I guess, is what I would say. Or maybe you could just start off by adding the 64-bit types to the Viper level, and then say, okay, if you're emitting WASM code, we're only going to let you use the 64-bit types initially, and then down the line, worry about emitting it. I'm just saying, like, there's already WASM code in place, already chunks of WASM code you can take that have at least some testing against them for being correct implementations.
That's roughly what I have in mind. So sort of have like I said, the stopgap one would support, let's call it Viper 1. It's not the real version, but it would be the EVM 1 version. And then I see adding 64-bit types being only sort of mashed together. But it's early days, so I'll see how it develops. But yes, that's roughly what I had in mind.
Okay.
Yeah.
Actually, there's one comment on on the ABI. So, right now the ABI on the part of interfacing with the contract, it usually starts with a selector, which is a 32-bit number, and which is then followed by the actual ABI encoded data. And this selector right now only is a hash of the function name and the input argument types, but it doesn't take the return types into consideration. And there has been an issue, I'm not sure if you guys are familiar with it or heard about it, but due to the way Solidity, the compiler in Solidity didn't do a couple of checks in the past, because it was kind of impossible to do them effectively before having the return data copy and return data size opcodes. It didn't do any checks whether the called function on a remote contract returned the expected data length, because there was no way to tell. And therefore, in ERC20 tokens, some of them, I think at some point, they have changed the interface of ERC20, the transfer function. And previously it didn't return anything, but after the change, it returned a Boolean. And they also changed the semantics, whether on an error it should return false or whether it should throw. But it was a big mix between these two. And some of the decentralized exchanges decided to take the newer version of the interface, where it expects a Boolean, and the Boolean has to return true if it was successful. And there was a change in the Solidity compiler when return data size was made available in Byzantium. And after that, basically what happened, I think roughly 5 to 10% of the tokens were broken if the exchanges were compiled with the recent Solidity version, which actually checked the length. I can give you the actual issue numbers which explains this in more detail. But what this sparked as a discussion is a potential change to the ABI, where the selector should include the return data types as well, and not just the input argument, the types of the input arguments. And if you want to include those in the ABI, that's already a breaking change. And if you do that, we could also consider looking at a different kind of ABI than what we have today. Sorry, this may have been too long as an explanation, but may be relevant to this discussion.
Yeah, I agree. That would be a perfect scenario to put it in. But even considering like the history, we must actually consider having some type of versioned ABI, perhaps. If you know what I mean. Because this is a perfect example that like completely backfired, and it's really difficult to patch post-mortem.
Yeah, the versioning also came up as a potential thing which should be added if such a breaking change is made.
Yeah, so that would allow breaking changes, and it would allow the client libraries to pack the data based on a version, kind of like catering for expansion later. Like you don't design something, like you kind of design it so you can expand it later. I think that would definitely be a good value add in the ABI design.
Yeah, I think versioning in general is something that needs to happen in a lot more places in the ecosystem.
Yeah, and the ABI would be a perfect use case, because you can have like the client knows, okay, this is VX, so I can't do this, and then like the contract can just assert based on like, I don't know, 8 bits even. It doesn't need to be much. Make it like 32 bits.
I guess, Everett, the only reason I mentioned this is it's definitely not an issue to support the current ABI, even if the language is designed to be 64-bit. But if we have this opportunity to maybe change the ABI because of these issues, then it may be useful to think ahead and look at 64-bit options.
Yeah, The reason why I suggested like thinking of a new ABI is basically because of the incentives, people are going to only be using 64-bit structures because it's going to be so much faster than the stopgap. Or there's no real reason to send all those 0 bytes just because of the old version.
I certainly hope so.
Do you guys want to move on to the naming discussion?
Alex, just one quick note, like a time check here. I'm going to have to end the call in about 15 minutes sharp. We can maybe go 2 or 3 minutes over. Let's just make the best use of time because it is a big topic.
Okay, I guess I can give like a 1-minute overview of what we would like to name. So one thing we have, I guess I start from this part, is EVMC, which started out as a C header defining an ABI, had to plug in a VM implementation into an Ethereum client. And where it started from is writing an EVM JIT in C++ and plugging it into the C++ client. And it also had the motivation to have it plugged into Go Ethereum. Over the years, this has evolved into a stable specification. It's called EVMC. Right now, it is supported on a client side by CPP Ethereum, and there's a prototype for Go Ethereum, and there's an outdated prototype for Pi Ethereum. But it's been proposed that maybe it should be supported by Pi EVM. On the VM side, it has 3 working VMs implemented in it. One of them is EVM JIT. The other one is a interpreter called Aleph interpreter, which is the old interpreter pulled out from CPP Ethereum. And the third one is Hera, which is the ewasm implementation. So this EVMC is defining an abstraction layer, had to separate the VM from the client. And there are considerations that there are ideas that this could be used as just an abstract layer, even if it's not C, but used within a client, even within the Python client.
I'd also like to add, Alex, that KVM also conforms largely to EVMC. Once I heard about it, I migrated it over to use the same status codes, for instance, in the same kind of naming conventions.
Yeah, the status codes is one thing. I'm not sure if you also use the rest of the abstraction. But yeah, this came up really as a discussion in Pi EVM/Trinity. The other thing we have right now is something called EEI, which started out as a list of functions contracts on ewasm can import from the client. And EEI stands for Ethereum Environment Interface. But it really seems like that it could be used as an abstract interface of what are the state a client exposes to a contract and how the state can be accessed and modified. And Everett has started to use EI as a term for this exact thing, this abstract thing in the K framework. And the last thing we have, which the EI was originally used for, is the actual list of functions a contract on ewasm can use. So probably these are the 3 things we have right now, and there's a confusion between them, between the naming of them. I'm not sure, Everett, do you want to take over from here?
That sounds pretty accurate in terms of my understanding of the situation. But yeah, the main thing is we're going to the Trinity folks with this proposal, and I just want to not be spreading more confusion with more different uses of the names. So yeah, I think when I was writing the EEI spec, I was thinking EEI was both layers. It was there's the EVMC, which is kind of the layer that the execution engine exposes to the client, in order to drive the execution engine and to get back information about what has happened during execution, like was it an out of gas or a revert or something like that. And then the EEI is the other direction, what the client exposes to the EVM. And initially I was kind of ballooning EEI out to cover both layers, but I think now EVM-C is kind of the execution engine side, and EEI is more the client side. But I still think that EEI should be more general than just ewasm, for instance, because you could think like, ewasm v 1.0, ewasm v 2.0 or something, right? You want, at least it to be, specific to each version of ewasm. Then beyond that, you would think, okay, I would also want to be able to support the different versions of EVM or something like that. So, so for my thoughts on it are, EEI would be the methods exposed, the state update and state getter methods exposed by the Ethereum client or Ethereum node to the execution engine. And the execution engine also exposes some kind of status codes and hooks for driving execution to the client. And then we could call that EVM-C, or we could call the whole thing EVM-C and come up with some other name for the smaller thing that is what the execution engine is exposing. But yeah, mostly I just want to make sure that I want to, like, let's decide on some names and commit to it type of thing, like let's just do that and move forward.
I think I would like to add one little thing to the EVM-C, is that we really need to make a separation, I think, between two things. If EVM-C is used for the abstraction layer, then the actual C ABI, which is what EVM-C right now is, the C ABI should have a distinct name, because it's one thing that a client has this internal abstract separation of concerns regarding the client and the state and the VM. And it's another thing that's a actual VM conforms to this ABI, and the client conforms to the ABI, and therefore VMs can be plugged in to the client.
Well, I guess I would just think of calling that as like, the C plus the CPP Ethereum implementation of EVM-C. You see what I mean? Like, I don't know that we need a whole new name for each language's implementation of the same interface as much as just saying, like, this is, the implementation of the interface in this language.
So it's actually not C++ related. This is more like an actual API and whatever system you're on. But it definitely works on the Mac and Linux or any kind of Unix or POSIX system. It's an actual API. Binaries can be compiled to. And if you have the VM compiled as a binary, then you should be able to, like, the client could use an FFI if it's a script language, or it could be an actual binary and would be able to load the binary without any issues. Whereas I think if it's just the abstract layer within the client, that may not be 100% compatible. Also, I don't think we will come to any kind of consensus during this call, but it's more like just raising the actual topic for discussion. And whoever is on the call, or whoever is watching this after, feel free to raise your voice and come to the ewasm lobby, which should be on I guess in the YouTube description as well.
Yeah, I don't know. I guess that seems like a pretty succinct summary of what's going on there. So I also think we should discuss this over text and pull requests more than over video call. So
Cool. Any last minute questions or updates? Okay, yeah, I think that's a good place to stop. Alex, Everett, thank you guys so much. That's I'm learning here as well, and this is just really, really interesting topics. As you guys said, we're not going to reach any conclusions on this call, so please join us in the ewasm Gitter channel. I posted that both on the public YouTube link as well as here in the meetup. Thanks, guys. We'll see you again in, I guess, 3 weeks for the next call. Hi, Greg.
Thanks, guys.
Thanks, guys.
Thank you. Bye-bye.
Thank you.